Z transform. So Z transform of any discrete signal is denoted by X of Z, where we have the X of Z formula is sum of minus infinity to plus infinity x of n Z power minus n. So whatever signal we need to find Z transform, that is Z transform of X of n is equal to whatever signal, the same signal. Apply this formula, we will get a Z transform. In Z transform, we have the concept called ROC, region of convergence. So it is a region where Z transform exists. It is a region where Z transform exists or converges. So we have the significance of a ROC is it gives the idea about the values for which Z transform can be calculated. Again, it is used to determine whether the system is causal system or not. Again, it is used to calculate the stability of the system. So significance of ROC is we have 3 points. Now next. So let us start with the Z transform of a very basic signals. The first one is step sequence. As we all know, the step sequence is denoted by U of n. It exists only on positive side starting from 0 to infinity. It can be expressed mathematical equation U of n is equal to 1 for positive value of n including 0. For negative value of n, the function value is 0. So therefore, Z transform of U of n is denoted by X of Z. They apply the formula sum of minus infinity to plus infinity U of n Z power minus n. So whatever signal we need to find Z transform, the same signal is present inside this U of n Z power minus n. Of course, this U of n value is 1 throughout the limit 0 to infinity. So this limit is reduces to 0 to infinity. Over the limit, the function value is 1. So 1 into again Z power minus n can be written as Z power minus 1 whole power n. So using mathematical series, sum of n is equal to 0 to infinity, a power n can be written as 1 by 1 minus a. Apply this formula. This summation is reduces to 1 divided by 1 minus Z power minus 1. So X of Z is equal to 1 upon 1 minus Z inverse. So here X of Z is equal to 1 divided by 1 minus Z inverse. We have the term called ROC in Z transform. So we will consider the denominator. In the denominator, we will consider Z power minus 1. In the denominator, we will consider Z power minus 1. Let us take this Z power minus 1 is equal to 1. Let us take Z power minus 1 value is 1. So Z power minus 1 value is 1. 1 minus 1 is 0. So 1 divided by 0 is infinity. X of Z value is infinity. X of Z value is infinity. So that means X of Z is not converges. Its value is infinity. So this case is not valid for finding ROC. Next one is when you put Z is equal to greater Z power minus 1. This Z power minus 1 value is greater than 1. When you put Z power minus 1 value is greater than 1. This X of Z value is negative value. So that time also the ROC is not valid. Again, when you put Z power minus 1, this Z power minus 1 value is less than 1. So less than 1 means that time X of Z have some value, positive value. So that case is valid. So among the three cases, it has a negative value. Their ROC is not valid. It has the infinity, it is not at all valid case. So the only case is Z power minus 1 less than 1. So Z power minus 1, again we can write 1 divided by Z less than 1. So here we can write Z greater than 1. Z greater than 1. So the ROC is a circle, unit circle. The circle value is 1. Greater than value, this entire area is ROC for step signal, unit step signal U of n.